In this video, we're going to talk through the solutions to the final exam review number 2 for semester 2 in Algebra 1. At the beginning, it says we're dealing with family of functions. So the first one says determine the function family and provide the prompted information. So when I look at this, I'm given a table, and I need to look for the pattern in the table. I recognize that x is increasing by 1 each time, and here as I look at y, I'm trying to think what happens each time. Well, here to go from 5 to 25, I'm adding 20, but then I add 100, so I'm not adding the same thing each time. It's not symmetrical in the table, so I know it's not quadratic or absolute value. So now I'm looking at my other options. Maybe I'm multiplying by the same thing each time. Well, to go from 5 to 25, I know I multiply by 5. 25 to 125, I multiply by 5, and I recognize that I keep doing this each time. Now, if I don't have, if I'm not able to do that in my head, I can always take any y value and divide by the previous one and see what the common ratio would be. So when I do that, I notice that I'm getting 5 each time. So this is a common ratio for the y values. So the family, if I have a common ratio as x increases at a constant rate, is exponential. I know that my exponential equations we can write in the form y equals a times b to the x, where a is the y-intercept. I know the y-intercept is when x is 0, so I got to work backwards. If I divide by 5, I get a 1, so I could write y equals 1 times b to the x. But if I'm just multiplying by 1, I know that doesn't change the value, so I'm just going to write this as b to the x, where b is the common ratio of 5. So again, the common ratio we get by what number are you multiplying by each time. And the a value was our y-intercept. And because it's 1, we don't have to write it. The y-intercept or intercepts, well, that's always when x equals 0. So when I look at x equals 0, I have 0, 1. And then the x-intercepts are when y equals 0. So I see that y is decreasing going in this direction. If I keep going, keep dividing by 5, I'll get 1/5 when x is -1. 1/25 when x equals -2, and I'll keep getting smaller and smaller, but what I'll recognize is that I'll never quite get to 0 for y. And then I remember that exponential functions, they will approach an asymptote but not cross it, which means I'm approaching y equals 0, but I'm never going to reach it, so there are no x-intercepts for this function. And if we looked at the graph, I go to y equals, we got our equation 5 raised to the x. I can look at the table and see no matter how small, times this e means times 10 to the -8th power. I'm just getting super, super, super small. If I look at the graph, I see that my graph will be approaching 0, but it's never going to cross that 0. I can even zoom in if I want to. And again, you see it gets closer and closer, but it's never going to cross it. So there's no x-intercept. When I look at number 2, I see a V-shaped graph, and I know a V-shaped graph is absolute value. My equation is going to be in the form y equals a times x minus h plus k, where h and k are my vertex. So because I went to the right 1 and down 4, 1 comma -4, and I'm going to have y equals my x, it'll be -1 minus 4. I also have to look at the slope, how the steepness. So I'm rising 2, running 1, and the graph is opening up, so the a value will be 2 over 1, or just 2. So I need to write a 2 out there. My domain, because the graph goes forever to the left and right, the x values can be all real numbers. The range is my y values, and y goes up and down. So as I go down, the graph will stop at that vertex, so the lowest y value will be -4. But then it goes up in both directions, so it'll be y is greater than or equal to -4. Scooching down, I'm looking at number 3. It says, what are the transformations of this function from the parent function f of x equals x squared? Well, when I look at this, I recognize that's vertex form of quadratics. So here, a is -2, h is -5. Remember, it's opposite the sign you see, and k is 1. When a is -2, this does two things to the graph. The negative makes this a reflection in the x-axis, and the 2 makes this narrower than the parent function, or a vertical stretch. Because h is -5, this is translating to the left 5. and k is positive 1, so I'm translating up 1. Remember, h moves it left and right, k moves it up and down. When I see a plus sign inside the parentheses, I know I'm going to the left, which is sometimes counterintuitive, but we've got to remember h is opposite the sign in the parentheses. Scooching down to number 6. Sorry, not number 6, unit 6, number 4. It says solve the equation. We're dealing with absolute value, so there's a couple things I need to think about with absolute value. If I have the absolute value of something equals 22, I could be taking the absolute value of two different numbers. I know that the absolute value of negative 22 is 22, and the absolute value of positive 22 is 22, which means what's inside here is either equal to negative 22 or 22. So I'm going to have two different equations. 2x plus 6 equals positive 22, and 2x plus 6 equals negative 22. So now when I solve, I can subtract 6 from both sides, and I get, that's 16. I then divide by 2. I get x equals 8. If I subtract 6 from both sides this time, I get 2x equals negative 28. And when I divide by 2, I get x equals negative 14. So this one has two solutions. So C would be the correct answer. I have another absolute value equation. This time the absolute value is not set equal to a number yet, meaning it's not isolated. So I have to first isolate the absolute value bars before I can do the same analysis I did in number 4. To do that, I subtract 8 from both sides. Those add to be 0, so I'm left with absolute value of 2x plus 3 is equal to 11. Now I'm taking the absolute value and I equal 11. That means what's on the inside is either equal to 11, because the absolute value of 11 is 11, or what's on the inside is equal to negative 11, because I could be taking the absolute value of negative 11 and get 11. So I then subtract 3 from both sides, and I get 2x is equal to 8. Divide by 2, I get x equals 4. When I subtract 3 over here, I get 2x equals negative 14. And now when I divide by 2, I get x equals negative 7. So this equation has two solutions. All right. Let's go down to unit 7, quadratics. We did a lot with quadratics, so we have to think through all of the information we know. So number 6 says find the product. I know that product means multiplication. Now, I'm not seeing multiplication right now, but I'm seeing squaring. What I need to remember is that when I square something, I'm just multiplying it by itself. And we talked about a couple different ways to multiply these binomials. We talked about the distributive property, or FOIL, and we talked about the area model, or the box. So to do this, I can just use the distributive property. 7x times 7x is a 49x squared. 7x times negative 3 is a minus 21x, minus another 21x, and plus 9. And I combine like terms and I get 49x squared minus 42x plus 9 is the expression. Now that's one way to do it. I could have also used the area model and done 7x minus 3, 7x minus 3. And I'll get the same four terms, they'll just be organized in a box. 7x times 7x is 49x squared. 7x times negative 3 is a negative 21x. Negative 3 times 7x is a negative 21x, and when I multiply negative 3 and negative 3, I get a positive 9. Now when I add these two like terms, that's where I get my negative 42x. So I still have 49x squared minus 42x plus 9 as my answer. So when I look over here, I got to be careful. There's a lot of signs that are different. So, all right, looks like it's this last one here. So be very careful of the signs. As I scooch over to number 7, it says convert the function into standard form. So I recall that standard form is y equals ax squared plus bx plus c. So when I look at this right now, it's an intercept form. To make it look like standard form means I have to multiply this all out so it looks like ax squared plus bx plus c. Again, there was a couple different ways we did this. One option is to distribute this 5 first, and when I do that, I do it to the first set of parentheses only. Now I can multiply these two together, either using the distributive property like I did before or the area model. I'm going to go ahead and do the area model this time. So I have 5x minus 40 and then x plus 8. x times 5x is 5x squared. X times negative 40 is a negative 40x. 8 times 5x is 40x. 8 times negative 40 would be a negative 320. Now I still have to combine like terms. So I have y equals, because I started with a y equals, my 5x squared. I combine my like terms. Those end up adding to be 0, so I don't even have to write it. And then finally, minus 320. And this is my final answer. Flipping to the back, I'm looking at number A. I'm still in quadratics. So let's find the x-intercepts. So I'm thinking x-intercepts. Well, no matter what equation I have, if I ask for the x-intercepts, I know that's when y equals 0. So I'm going to set 0 equal to 8x squared minus 24x. And then I have to think through what form this is. Because I have an x squared and an x, I know that's standard form. And when I'm solving an equation in standard form, the first thing I'm going to try and do is solve by factoring. I know that my first step in factoring is to factor out the GCF. So when I look at these two terms, I only have two terms. I know that both 8 and 24 are divisible by 8, but I also see I have an x squared and an x. So I could also factor out an x in this common factor. So when I do that, I have 0 equals, my GCF is 8x. 8x times x gives me the 8x squared, and 8x times a negative 3 gives me negative 24x. Now that I look inside the parentheses and I see I have a linear factor, meaning I don't see anything squared, it's just an x minus 3, I realize I can stop because I can't factor this any further. Instead, now that it's factored, I'll use the zero product property and I'll set each factor equal to 0. So I have 8x equals 0 and x minus 3 equals 0. And when I solve, I get x equals 0 and x equals 3. But it's asking me for the x-intercepts, and whenever it asks me for the x-intercepts, I know my answer looks like an ordered pair. So this is how I'm going to write my final answer. These are the two x-intercepts. And again, if I want to check my answer, I have this great tool of my graphing calculator. So to check my answer, I could go to y equals, and I could enter in this 8x squared minus 24x, and I can look at the table. When I look at the table, I'm thinking, well, what am I going to look for? Well, I'm going to look for when y is 0, and I don't see y equals 0. So let's go over. We're getting closer. We're getting smaller to 0. Okay, good. Now we're getting a lot closer. There we go. 0, 0 is one x-intercept, and 3, 0 is another one. I could also look at the graph. Now, we're zoomed in too much. Let's go to zoom and then go down to number 6, Z standard. Get back to our normal viewing window. Here, I can see that we have 0, 0, and 3, 0. So I can check my x-intercepts that way too. Okay? All right, now moving on to number 9. Still in quadratics. So we're still thinking quadratics. It says find the value of c that would make this a perfect square trinomial. Now remember, a perfect square trinomial is a trinomial that you can factor and you get the same thing in both spots so that you can write it as something squared. So when I'm thinking about this, I'm thinking, well, I'm going to factor this. I'm going to get two things that multiply to be a times c. Well, a is 1, so this will just be c. Multiply to be that top number, and I add to be 16. But I know I need the same number here and here. Now, I can reason through that. If I have the same number and they both add to be 16, I know that that's 8 and 8. But if I don't do that mental math well, if I have the same number that adds to be 16, I can just take that 16 and divide by 2 in order to get the 8 and 8. Well, now I need to get the c, though, and these two numbers are going to multiply to be c. So 8 times 8 is 64. Or you could take that number, 8 squared, and get 64. 8 times 8 are 8 squared. So c would be 64. And that would be the answer. And the reason being is if I have x squared plus 16x plus 64, I want two things that multiply to be 64 and add to be 16, that would be 8 and 8. I can skip the box because the a value is 1, so this would just factor to x plus 8 times x plus 8, or x plus 8 squared. So this is my final answer, but this is why 64 works. Moving on to Unit 8, number 10. We're wanting to simplify. When I simplify, I need to look at what operation is going on. And I see addition. Anytime I see addition with polynomials, I know that I just have to combine like terms. So I have a 7x to the 4th, and a negative 7x to the fourth. Well, those add to be 0. Cross those out since they add to be 0. Now I move on to the next term. I see an x squared term. That is a negative 9x squared. There's no other x squared term, so I don't have to worry about it. And then I see a positive 9 and a positive 2 for my x term. So 9x plus 2x will give me plus 11x. There's nothing else that I can combine, so here's my final answer. So we have a quadratic binomial as our final answer. Looking down here, it says find the greatest common factor. Well, we have 3 terms, so I got to be a common factor of all of these. So I can list all the factors of each of these, or I can look at the lowest number. I know 15, the only numbers 15 is divisible by is 1 and 15 and 3 and 5. These are the only possibilities for 15. So let's look at these other ones. I'm thinking, well, which number is 80 divisible by? Well, looking over here, 80 is divisible by 1 because 1 times 80 is 80. Is it divisible by 3? No, it's not. Is 80 divisible by 5? It is. So we know 80 is divisible by 5 because 5 times 16 is 80. Well, is it divisible by 15? It's not. Okay, so these have in common. And we want to make sure that 25 is divisible by 5 as well. And 5 times 5 is 25. So they are all divisible by 5. So when I'm looking at the GCF, I know that 5 is a number that all of these is divisible by. Well, so looking at my answer, that eliminates D. But now I have to decide, is it 5x squared, or 5x to the fourth? Well, let's look at these. We have x to the 7th. So if I think of x to the 7, that's 1, 2, 3, 4, 5, 6, 7 x's. X to the 6th would be 1, 2, 3, 4, 5, 6 x's multiplied together. And x to the 4th would be 1, 2, 3, 4 x's multiplied together. Well, the greatest, or the most that they have in common, would be x to the 4th. So B is the correct answer. Still in our Unit 8, moving on to polynomials and radicals, we have radicals now, or square roots. And it's asked me to simplify. Well, when I look at this, simplifying here means that I'm adding, and I know I can only add if the radicals are the same, or really the radicand is the same. And the radicand here is 24, and this one is 150. So I'm going to try and simplify these radicals if I can. There are a couple different ways that we simplified radicals, so let's talk through this. The square root of 24, I can use the factor tree method. I know that 12 times 2 is 24. 2 is a prime number. I know that 6 times 2 is 12. And 3 times 2 is 6. So then when I simplify this one, I'm thinking, well, that's the square root of 2 times 2 times 2 times 3, or the square root of 2 squared times 2 times 3. And the reason I wanted to write it as 2 squared is because I know I can take the square root of perfect square. So the square root of 2 squared is 2. Square root of 2 is going to be irrational, and square root of 3 is irrational. So 2 times 3 under the radical would be just 6. So I know I have that. Now there's another way I could have done this. I could have just said, well, what's the largest perfect square that 24 is divisible by? So the other way would be to say, well, I can break 24 apart to the square root of 4 times the square root of 6, because 4 is the largest perfect square that 24 is divisible by. Well, square root of 4 is 2, and square root of 6 is irrational, so we simplify there. This way is much faster as long as you know your perfect squares. I'll do the same thing for square root of 150. Again, if we don't know our perfect squares, we can always make a factor tree. Because it ends in 0, I know that's divisible by 10. So 15 times 10 is 150. This would be 5 times 3, so we got there. And then 5 times 2. So now when I simplify, I have 5 times 5 times 3 times 2. And I'm going to pair these up because that's a perfect square. So 5 squared times 3 times 2. Well, the square root of 5 squared is 5. Square root of 3 is irrational because it's not being squared, and so is the square root of 2. So 3 times 2 under the square root is 6. Again, the other way I could have done it is just think through. If I have the square root of 150, what's the largest perfect square that 150 is divisible by? So my perfect square is being 1, 4, 9, 16, 25, 36. Well, as I go through these numbers, I recognize that the largest perfect square 150 is divisible by is 25. And I know that 25 times 4 is 100, so 2 more would give me the 50. So 25 times 6 would be 150. Square root of 25 is 5. Square root of 6 is irrational, so I leave it square root of 6. So you can see you get the same answer. Again, this method is faster as long as you know your perfect squares. So now we've simplified these expressions. So instead of square root of 24, I'm going to write this as 2 times the square root of 6. And instead of plus 100 and square root of 150, I'm going to write plus 5 times the square root of 6. When I add these, I can kind of think of this as like terms. I keep the radical the same, and I add the numbers in front. So if I have 2 of the square roots of 6 plus 5 more, that'll give me 7 of the square roots of 6. And this is my simplified answer. So when I go back, if this is a multiple choice answer, C is the correct answer. Moving on to the very last problem. I want to simplify square root of 144. Now I'm going to break this apart, simplifying the square root of 144 and simplifying the square root of x to the 6. And then we'll combine our answers at the end. I recognize 144 is a perfect square. I know that 12 times 12 is 144, so the square root of 144 must just be 12. Well, that was fast. Square root of x to the 6th, well, I'm going to think about it this way. X to the 6th is really 6 x's multiplied together. That's 1, 2, 3, 4, 5, 6. I know how to take the square root of perfect squares, so I'm going to group these into perfect squares. So that's really the square root of x squared times x squared times x squared. Well, the square root of x squared is just x. Square root of x squared is x. Square root of x squared is x. Well, x multiplied by itself 3 times is x to the 3rd. So these are all equivalent. So I have 12 and I have x to the 3rd. My final answer is just multiplying those together, 12x to the 3rd. Another way that sometimes people look at this is that you realize that if it's an even number, it's just half of it, so you could take x to the 3rd when you're taking the square root. The reason that happens is that really when you take the square root, you're raising it to the 1/2 power. And a power to a power, I remember that I multiply, so that would be 6 times 1/2, or 6 to the 3rd. So this is another way to think about it, or we can expand it. And that is the rest of our final exam review number 2.